Let us talk about UJT circuits operation. Let us have a look at the UJT equivalent circuit. And this is the basic structure of the UJT. Now this is the PN junction. The PN junction is represented by this diode here, because a diode, as you know, is made up of P and N semiconductor material. This is a P and N semiconductor material, so it is represented by the diode here. What about this resistance here? R prime B2 represent the internal dynamic resistance between emitter and base 2, while R prime B1 represents the internal dynamic resistance between emitter and base 1. As you can see here, this internal resistance represents or forms a voltage divider network, and the ratio between R prime B1 and the total base interbase resistance RBB is called intrinsic standoff ratio, represented by eta. Now why is this important? The manufacturer gave us eta value here. For example, we have an eta value of 0.56. Let's say I am biasing my UJT with 6 volt. For example, 6 volt multiplied by eta, I will get 3.36 volts here. Now why is this important? Because the diode will remain reverse bias until the net voltage across the diode exceeded its forward breakover rating. Now, a simple question. This is a diode. How do you turn on a diode? You forward bias it. With what value? 0.7 volt. So at 0.7 volt forward bias, your diode is forward bias, which means that your diode is on. Let's say I am biasing it with 3.36. So this minus this is 0 volt. In order for me to turn on my UJT, I need to forward bias this diode. So I need to add 0.7. So I need to bias my emitter to base 1 terminal with an additional 0.57. So that's why the diode will remain reverse bias until the voltage across this diode is greater or exceeding its forward breakover rating, in which for a diode it is 0.5 to 0.7 silicon. The value in which the PN junction became forward bias is what you call peak point voltage. We will elaborate this more in the characteristic curve. Now, let us talk about post-conduction. What happens when the UJT is turned on? This is before it turns on, or to the moment before it turns on, and this is the moment where it turns on. When the UJT is turned on, your emitter current rises regeneratively, but your emitter voltage falls drastically until saturation. So let's say I reach saturation point, but I still want to try to increase my emitter current. So what happens? If I try to increment my emitter current beyond saturation, it will only result in very slight increase in emitter voltage. So that concludes the equivalent circuit operation. On the next topic, we will talk about the characteristic curve operation.